The anxiety driving this video isn't that AI will replace you tomorrow. It's the immediate, terrifying feeling of being handed a full-stack mandate because your company thinks an LLM can do everything. You are now expected to be the front-end developer, the back-end architect, and the QA tester simultaneously, all while managing probabilistic outputs from black box agents. This isn't about becoming a superhuman coder. It's a fundamental architectural failure in how companies are deploying AI right now. The solution isn't learning more languages or working harder. It is abandoning the code generator mental model entirely to become an infrastructure manager for autonomous microservices. For decades, since that pivotal 1968 NATO conference on software engineering, our industry has operated on a single foundational premise: humans must manually encode static decision logic into permanent artifacts. We write functions, we define classes, and we assume the code will execute exactly as written every time. This deterministic approach worked for 50 years because it gave us control. But now, when you hand an LLM your project requirements, that model does not produce a fixed artifact in the same way. It generates ephemeral tooling only when needed, often discarding its own logic afterward to adapt to new context. When management tells you to use AI tools to handle everything from user interfaces to database queries and quality assurance testing all at once, they are asking you to apply a 50-year-old mental model to a fundamentally different technology stack. You feel the burnout because your brain is trying to write static code while managing dynamic systems that can fail in unpredictable ways. The anxiety comes from realizing that if an agent hallucinates or makes a logical leap during execution, there is no manual fix you wrote yesterday to catch it. The answer lies not in working faster, but in shifting how we architect the entire system. We must stop treating AI as a code generator and start building systems designed specifically for probabilistic failures. A compelling example of this shift can be found in clinical workflows where reliability is non-negotiable. Research into the Maria platform demonstrates that successful agentic systems require 4 specific pillars to function at scale: clean architecture for maintainability, event-driven patterns for resilience against those inevitable hallucinations, and a dedicated MLOps lifecycle where each agent operates as an independent unit with its own governance loop. Quick resource note: I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. In this model, code is not permanent. It is generated on demand by the large language model only when required to solve a specific subtask, then discarded immediately after execution. The developer's role shifts from writing static decision logic to managing the infrastructure for these autonomous microservices. You become an orchestrator who ensures that if one agent fails or produces incorrect output, the system can detect it and route around the error without crashing the entire application. This is not a theoretical concept. This is how production systems are surviving today in high-stakes environments like healthcare, where errors cannot be tolerated. This architectural shift explains why your current workload feels impossible to manage. You are trying to solve an infrastructure problem with a tooling mindset that assumes everything works perfectly every single time. The industry has already begun mapping out the future of this transition through extensive analysis of work patterns across hundreds of occupations. A major study auditing over 800 tasks in 104 different U.S. jobs revealed a critical mismatch. While AI can automate significant portions of routine work, high-value tasks remain trapped in what researchers call an R&D opportunity zone because current technology cannot yet handle complex human nuance or probabilistic failures without active oversight. The data shows that the future isn't about total automation replacing humans line by line. It is a shift where developers evolve into agentic engineers who orchestrate autonomous components and manage the failure states inherent to non-deterministic algorithms. This role requires you to stop acting as a writer of deterministic instructions and start building systems where you manage the agents, their probabilistic outputs, and the audit trails that prove they worked correctly. Educational research from 3 years of practice-oriented training programs confirms this evolution in real time. Successful AI engineers stop treating models as magic boxes and start embedding human-in-the-loop governance directly into the data flow. This is not just a safety checkpoint where a human reviews code before it runs. It is an event-driven source for continuous model improvement that actively feeds feedback back into the system to correct errors over time. The emerging job market reflects this reality, with over 50 distinct new roles cataloged in recent years, such as AI Data Remediation Engineer and Incident Response Commander. These titles signal a move toward specialized oversight of agent behavior rather than generalist coding for every single function. If you are currently feeling overwhelmed by a mandate to be full-stack using these tools, the path forward is not to learn more frameworks or write faster code. You must change your mental model entirely. The immediate takeaway is that agentic engineering requires treating AI outputs as probabilistic events rather than deterministic instructions. Your value now lies in designing systems where you manage autonomous agents and their failure modes, making you indispensable because you are the only one who understands how to keep these non-deterministic systems from collapsing under their own complexity. You cannot simply learn more languages or work harder. The paradigm has shifted from writing code to managing infrastructure. The future belongs to those who can build robust architectures that handle uncertainty gracefully rather than trying to force a deterministic mindset onto probabilistic tools. This shift turns your role into an infrastructure manager for AI microservices, ensuring you remain essential not because you can write more lines of code, but because you are the guardian of system reliability in an era where every line might change on its own terms. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.